Now we're going to do multiplying and dividing by rational expressions. So we have to remember what we did yesterday with factoring and reducing and simplifying rational expressions. We also have to remember back to how to multiply to rational expressions, fractions. I'm going to do a simpler problem than this. If I just have 2/3 and I'm multiplying times, let's do 3/4. Recall that when we multiply straight across the top and straight across the bottom, but before we multiply, we can cancel anything on top with anything on bottom. So this 3 can actually be reduced with this 3, and this 2 and this 4, which is 2 times 2, can be simplified. So our final answer would be 1/2. So that's what we're going to need to do. We're going to need to try and cancel stuff and then multiply across the top, multiply across the bottom. Okay, so here's the one I'm looking at doing with you. Let me zoom in a little. All right, so the top we have 3 times x, and the bottom is just x plus 2. There's nothing else you can do with that. Over here, the bottom is just x. The top, because it's a trinomial, we can hopefully split it into 2 binomials. So we have x and x. We need it to multiply to 2 and add up to 3. So 1 times 2 multiplies to 2, adds up to 3. Now, as far as canceling goes, we're going to cancel this x with one of these x's, and we're going to cancel this x plus 2 and this x plus 2. And then what remains is our answer. So we have a 3 and an x plus 1 on the top. Oh, and another x in there. I missed that one. 3x and an x plus 1 on the top. And nothing on the bottom. So you could just leave it like that, or you could put it over 1. Now, with dividing, if you recall, when we were dividing fractions, if we had 2/3 divided by, let's just make it 4/3, the way we solve a division problem is by multiplying by the reciprocal. So the first fraction stays the same. We change the division to multiplication, and this fraction becomes the reciprocal. We flip it upside down, and then we multiply, just like we just did up here. All right, so for our division problem that we're going to take a look at, we are going to flip this second fraction and make it a multiplication problem, and then factor it all out and cancel like we did with multiplication. So I just rewrite the problem. Usually when I'm writing this down from a book or from the computer, I simply rewrite it as I'm putting it down. I wouldn't write the original problem. I would just flip this around right away. And then from there, I would try to figure out what it factors to and do my canceling. So this first problem, the 4 will factor out and we'll have a k plus 2 left. On the bottom one, a 2 will factor out and we will have a 3k minus 5 left. The top, a 3 will factor out and we will have a 3k minus 5 left. And the bottom here, we end up with, let's see, k plus 4 and k plus 2 when we factor that, because we need it to multiply to 8 and add up to 6. Now, as far as canceling goes, we want to cancel the 3k minus 5, the k plus 2. This 2 will cancel with that 4 and make it go down to a 2, and I believe that's what's left. So we have a 2 and a 3 on the top. These are multiplied, so we can make that 6. And we have a k plus 4 on the bottom, and that's our answer. That's our reduced answer to this problem. All right, I want to mention this. A complex fraction is a fraction that has more than one fraction bar in it. So within that one piece. So we have 1, 2, 3 fraction bars here, so this is considered a complex fraction. So multiple fraction bars. Now, this problem is really similar to the problem I just did. You just have to realize that this is a division problem. So 1 over q plus 4 divided by 2q squared over 2q plus 8. This is the division problem that we have here. So when we're working this out, we will have the 1 over the q plus 4 times the reciprocal of this. And then from there, we could factor it and cancel anything that we could cancel to get our reduced answer. So that's all a complex fraction is.